Hi, this is Algebra 1, um, Module 3, Lesson 2, Floating Down the River. Now we're going to focus on those key features of the functions and being able to identify them. So, Alonzo, Maria, and Sierra were floating in inner tubes down a river, enjoying their day. Alonzo noticed that sometimes the water level was higher in some places than in others. Maria noticed there were times they seemed to be moving faster than at other times. Sierra laughed and said, "Math is everywhere." To learn more about the river, Alonzo and Maria collected data throughout the trip. So here's their table that talks about the time and minutes they were going and then the depth of the water. So we're going to use this data collected by Alonzo to interpret the key features of this relationship. So key features. Let's start with listing all of those. So our key features are domain. I can get them all to fit in here. Range. And then we have increasing. And we have decreasing. And then we have maximum. We have minimum. And we have y-intercepts. I don't believe we have an x-intercept on this one. Yep, there's no point in here where x equals or y equals 0. So these are the features of the functions that we are going to look for. So let's start with our domain. Let's do this one in green. Domain is our x value. So time is our x value in this case. So our domain basically goes from 0, and then it goes all the way up to 120. So how I'm going to put that is I'm including 0 and 120. So I'm going to do a bracket, 0, all the way to 120. Doing the brackets so it shows that I'm including those two numbers. So now range is going to be our y. So depth is our y in this case. And we want to find the smallest and the largest. Well, here's a 4. That looks like it's pretty small. 6, 8, 10. Yep, there's nothing smaller than 4. How about our highest? 10. Keep going through. Oh, 12. 12 looks like our highest. So it looks like we can pretty much have anything kind of from 4 to 12, right? So I'm going to do, again, enclose the brackets because we can have 4, we can have 12. That's our range. So now increasing intervals. Our increasing interval, pardon me, is anytime ours is going up. So in this case, here we're going from 4 to 6 to 8 to 10. That's increasing, right? Now we're going down 6, 5, 4. Oh, here we're going again. 4, 5, 7, 12. And then we go back down. So our increasing intervals, we would have, it starts at 0, from 0 to 30, because that's where we're 0 and 30. And we're going to include 60 to 90. So we need both of those in there. So both of those will work as our increasing intervals. Now, as far as decreasing goes, what color can we use here? Let's use our pink for this one. So for decreasing, we noticed at 10 is where we were starting to go down. Those look really alike. Let's pick a different color. Let's do a yellow. Okay, erase that line. Okay, so with our yellow, let's do decreasing in yellow. So we 10 going down to 4, and then we did 12 going down to 5. So I'm going to write this as we have starting with 30, going to 60, right? 30 to 60. And we have 90 to 120, because 90 all the way up to 120 is our decreasing intervals. All right, so now we need to find our maximum point. So where on here, run out of colors. Let's do our pink for this one. So our maximum point is going to be our largest y that we have. So our y, its largest. So we said 12, into my color here, 12 was our, pick a different one. Go back to, we'll do black. Black. So 12 was our maximum. And so that's at 90 minutes. So we're going to say 12 feet, because that's our depth, at 90 minutes. And so our minimum then will be the shortest amount we have. And right now we have a 4, we said was our smallest, but we have it also at 60. So 0 and 60 both had 4. So we'll put both on here. 4 feet at 0 and 60 minutes. And then our y-intercept is going to be where our x equals 0. Well, in this case, x equals 0, y equals 4. So we have found all the different pieces of this function by looking at our table. So Maria created a graph by collecting data on a GPS unit that told her the distance she had traveled over a period of time. I'm going to draw over this in the yellow so you can see a little better what's going on here. Okay, and so here we have 50. Here we have 100. We've got all of our lines in between here. 40, 30, 20, 10, 0. Here is our axis. And she has this starting at 2,000 distance. This is our distance. And this is our time. So 2,000, 4, 6, 8. Here's 10,000. And then 12, 14, 16. So you know what? I'm going to erase these two. Why is it not going? I'm not wanting to cooperate with me today. Okay, so 2, 4, 6, 8. Here's the 10,000. I don't know why this is not going to work for me. Technical difficulties. Sorry about that. Don't know what's. So the 10,000 is going with 4, 6, 8, 10. This mark right here. Okay, so using this graph described by, now it's not letting me click anything else. Okay, so now on here, using Maria's graph, describe the key features, increasing, decreasing, domain range, maximum, minimum intercepts of this relationship. So again, we're going to do all those pieces we just did. I'm going to zoom out just a tad so we can see our graph and I can get those all written out. All right, so we started out with writing everything in purple. So let's do that again. So we have domain, range, we have increasing, we have decreasing, we have maximum, we have a minimum, and we have a y-intercept. And let's go ahead and put x-intercept on this one. Okay, so as we're doing this, domain. So our domain is our x values. So basically from here all the way to where it stops over here. So again, we start at 0, we end at 120, we have a bunch in between. The y is the same idea as well. We started here, we went all the way up to here. And so in this case, we have 12, 14, 16,000. So our range here, since it's a distance that they're traveling, it's 0 to 16,000 is our range. Increasing. Our increasing sections, well, if we look, it's going up, 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 pretty much the whole way, right? So our increasing intervals are 0 to 120. All the minutes, the whole time, it's increasing. And that means it's decreasing never. So we don't even have any decreasing segments, do we? Whole thing's going large, going up. All right, maximum. So the maximum point would be this guy right here. Oh, shouldn't use black for that one. Let's go and we'll go ahead and we'll do our green. So maximum point is right up here. So that is 16,000 feet at 120 minutes. And our minimum would be right here where we started, 0. Oh, I don't need the parentheses. 0 feet in 0 minutes. And that puts us as our x and y intercepts. Really, here's where it's crossing both of the axes, right? So our y-intercept would be 0, 0, and our x-intercept would be 0, 0. So because this one is doing a distance, you're not going to go backwards because you're going down a river, so you're going to always keep getting farther. And then your time is always going to be increasing. So it's a function that is only going up and out, basically. All right, let's look at the next page. So part 2, just interpreting data. Sierra looked at the data collected by her 2 friends and made several of her own observations. Explain why you either agree or disagree with each of the observations made. So the depth of the water increases, stuff as we go. The depth increases and decreases throughout the 120 minutes of floating river. Well, I agree with that, because we did have moments of increase and moments of decrease when we were looking at that first graph. Okay, so B, the distance traveled is always increasing. Was that true in our second graph? It was. We were always increasing when we were traveling. The distance traveled is a function of time. So, is there a distance for every time? Yes, there was. There was no overlapping in that one. For D, the distance traveled is greatest during the last 10 minutes of the trip than during any other minute interval of time. I don't remember this one. Let's go back and look. The distance traveled was greatest in the last 10 minutes of the trip. So we're looking at last 10 minutes. So here's the 120. This distance is the fastest they've went through the whole thing. The distance traveled is the greatest. So they basically went 2,000 feet in 10 minutes. Not necessarily, because it looks like they kind of did a similar thing over here. Kind of had some steep spots on this side too. So I'm going to disagree with this, because I think there was more than one spot where they were going that fast. So this one's going to be a disagree. Okay, next. The domain of the distance time graph is all real numbers. So if we do the distance and time graph up here, is all real numbers. Well, distance, time, it looks like we've connected them. So we could do all real numbers, couldn't we? So that one I'm going to agree with. Okay. F, the y-intercept of the depth of water over time function is 0, 0. So this was the first one, the table. Was the y-intercept 0, 0? I don't believe it was. I believe it was 0, 4, wasn't it? Yep, right here, 0, 4. That was our y-intercept over here. So that one is a disagree. The distance traveled increases and decreases over time. But when we did that distance traveled, we said it only increased, right? That was it. It didn't decrease. So I'm going to disagree here. Again, only went up. The depth of the water is never 11 feet. When it says never, now 11 feet was not in our table, but would it hit 11 feet at some point? So I am going to disagree, because when it goes from 7 to 12, it has to hit 11 somewhere. Now, it's not on our table, but logically we know it has to hit 11 feet at some point. I, the range of the distance time graph is 0 to 15,000. Nope, we said that was 16,000, wasn't it? So we're going to disagree. The domain of the depth of water with respect to time is 0 to 120. So the domain of our depth to time, so up here, is it 0 to 120? Yes, it is. Oop, too far. So we can agree with this one. Okay, the range of the depth of water over time is 4 to 5. No, I believe our range we said was 4 to 12, because it got to the depth of 12 at one point. Okay, the distance time graph has no maximum value. We put in a maximum value, didn't we? Our maximum value was 16,000 feet at 120 minutes. So, so let's go back to here. So we're going to disagree. It was 16,000 at 120 minutes. The depth of water reached a maximum at 30 minutes. Well, let's see. Depth of water, 30 minutes. So that's this guy right here. It did not reach its maximum, because its maximum was over here at 90, wasn't it? 12 feet at 90 minutes. So we would say disagree. But what it was, so at 30 minutes, it was don't know how to get this off here. So at 30 minutes, it was a relative maximum. There's just an extra bonus word for you. This term, a relative maximum. So for that time, it was a maximum, but it was not the maximum of the graph. All right, so that is it for lesson 2. Make sure you read things carefully as you're going through them. And thanks for joining us.